Quatrième candidat, the fourth candidate to come on the stage is Maria Marcinek. Yes. How are you, Maria?
I'm good.
Happy to be here?
Yes, very happy to be here.
Your thesis is on plant beneficial bacteria as vectors for the active delivery of nanoagrochemicals.
Indeed.
At the Polymers Laboratory.
Yes.
With Professor Harm Anton Klock. So, enjoy. It's your time.
Thank you very much. About 1 in 10 people in the world are starving. It's quite a scary number, considering that the world human population is constantly increasing. This makes food security one of the major global challenges of the 21st century. Today, around 50% of the habitable land is used for agriculture, and further expansion is no longer a viable option. So how can we improve our farming practices to produce more food in a more sustainable way? One of the solutions to increase crop yields is to use fertilizer, which is essentially food for plants. Nowadays, a huge amount of fertilizer is applied by spreading it across entire fields. And while some of it can be used by the crops, a significant amount is lost, causing environmental pollution. It's a little bit like taking painkillers. The drug that you swallow travels everywhere in your body, which reduces its efficiency and often causes side effects. So what we need is a targeted delivery system that will allow us to bring our fertilizer directly to the plant roots. Imagine, instead of spreading the fertilizer across the entire field, we enclose it into nanoparticles, very small particles, which can be made of natural polymers, like proteins or carbohydrates. By modifying the chemical structure of these polymers, we can control how fast our nanoparticles degrade in soil and release fertilizer. But we still need to deliver those nanoparticles to the plant roots without losing them on the way. Well, it turns out that there are certain plant beneficial bacteria, good bacteria, like the ones in our yogurt, that live in soil and can naturally migrate towards plant roots, as if they had a GPS that tells them where to go. In my thesis, I'm investigating whether we can use such bacteria as taxis to deliver the polymer nanoparticles with fertilizer to the plant roots. To do so, I'm attaching the nanoparticles to the surface of bacteria using different chemical reactions and investigating how different loads influence their ability to migrate towards plant roots. It's not an easy task, though. After all, you too probably don't like carrying too much on your backs. By combining bacteria with polymer nanoparticles, we hope to construct an efficient targeted delivery system using smaller doses of fertilizer and causing less harm to the environment. And while my colleagues and I are doing our best in the lab to work on this strategy, it's only one possible piece of the global puzzle. It will take many different solutions to have a real impact on food security and the well-being of our planet in the future. Thank you.